If the best performing pharmaceutical suspended particles are small, meaning nanoscale, solid, and similarly sized, pharmaceutical suspensions are dispersions of insoluble solid particles. Small particles similar in size can be more evenly packed, making them more stable. There is the source. Then why, when comparing the X-ray shielding performance of fine ferric oxide powder composites for a technical white paper to a U.S. Missile Defense Agency broad area announcement seeking lightweight advanced material alternatives to lead, did the nanoscale ferric oxide powder mostly sink to the bottom of the cured silicone rubber composite samples? Independent helical CT scanning by Nikon in Michigan. This is our sample 2. This is an X-ray that displays nanoscale ferric oxide particles on the bottom of the mold as white dots. This is a 15-panel scan of horizontal X-ray cross-sections taken at various heights. The top right image is the bottom of the mold, and the bottom left image is the near middle of the mold. This is an X-ray video of nanoscale ferric oxide particle aggregation. Video starts at the top of the mold, ends at the bottom. White dots are aggregating particles. When all 3 nanoporous ferric oxide powders with grain sizes 154 to nearly 500 times larger than the nanoscale sample, with surface areas 2 to 5 times greater than the nanoscale sample, with non-similar grain size ranges 25 to over 4,700 times wider than the nanoscale sample, and with nanoporous non-solid particle architectures, did all 3 nanoporous ferric oxide powders display near uniform suspension and dispersion? Sample 3, 15 panels display. Here's the X-ray video, starts at the top of the mold, ends at the bottom. No white dot aggregation. Sample 4, 15 panel display. X-ray video starts at the top of the mold, ends at the bottom. Sample 5, 15 panel display. And the video starts at the top, ends at the bottom. Achieved visibly superior particle suspension and dispersion compared to the nanoscale sample. Not using sophisticated laboratory mixing methods like molecular monolayering or sputtering, but instead by using the simplest of mixing methods, manual stirring. Interior nanoporous cavities, when not fully saturated in the suspension fluid, retain interior cavities as air pockets, which causes grains that aren't completely saturated to self-identify as requiring additional stirring by floating to the top of the mold shortly after manual stirring ceases, signaling to the lab tech that more stirring is required for particle suspension and dispersion homogeneity to be optimized. 2 additional theories: nanoporous particles are less dense and hence more buoyant than solid particles. Number 2, solid particles are characterized by slippery exterior skins that minimize exterior surface shear, a property nanoparticles do not share. Additional information at the link below. Make sure the N in Nikon is capitalized so that you don't get a 404 error.